Okay, so let's get started. We're going to be taking a look at setting up and working with our dome pressure style boost control found in our Link G5 and G4X programming. Now, our dome pressure control is going to be quite a bit different compared to the manifold pressure based boost control we've discussed in the last few training modules. We know with the manifold pressure based boost control, we have both open and closed loop methods that we can work with. That's going to be using a single 3-port solenoid, and it's going to essentially be transferring manifold pressure, boost pressure that we generate, to the top port of the wastegate. So if we have a 3 psi wastegate spring installed in our wastegate and we're transferring whatever the boost pressure we're building through the boost control solenoid to the top of the wastegate, we may only be able to achieve something like 18-20 pounds of boost. So we're going to be limited in the range that we can actually adjust, and we always have to constantly change the wastegate spring in order to give ourselves more or less boost pressure, essentially giving us the control range with that single 3-port solenoid. Now, it's definitely going to be advantageous to run manifold pressure based boost control for a street vehicle because it's very simple in the setup and control. When we're talking about dome pressure control, now we're going to be introducing a CO2 tank that's regulated at a certain amount of pressure coming out of the tank. We're going to be feeding that into 2 different boost control solenoids. There's a fill and a bleed solenoid. We're going to be pumping that into the top port of the wastegate, controlling how much pressure we're transferring into the top port. We're actually going to be monitoring with a separate sensor the dome pressure. That's that top hat port pressure. That dome pressure is going to be adding to your spring pressure. So we can have a 3-pound spring in our wastegate and achieve 60-80 psi of manifold pressure if we desire, based on how much dome pressure we're applying to the wastegate, essentially how much CO2 pressure we're starting to bring into that top port of the wastegate. So this is a very effective way to control power and torque for an engine that might be traction limited, or if you're talking about just spring pressure and trying to get the boost out of your turbocharged system, it allows you to control over a greater range and a greater amount of boost pressure compared to just running a spring and feeding manifold pressure into a single 3-port boost solenoid in the traditional sense for the open and closed loop methods we've already discussed. So it has a lot of advantages for a drag vehicle. This is something that we don't want to run on a street vehicle because you don't want to have to worry about what your CO2 tank pressure is going to be, or whatever the bottle pressure is going to be at, or the bottle amount, how much CO2 is left in the tank. If you start to run out of CO2, well, then you're not going to be running any boost. You're going to be stuck. So this is primarily a drag-based style control. Let's jump in here and talk about what we have in terms of the components in the dome pressure control system, how they have to be laid out, the very specifics. We're going to go over a schematic, and then we're going to assign all of them here in our dome pressure control for programming, and then we'll take a look at how we can actually set up our dome pressure control without even running our engine. We can use regulated air pressure coming into the system and actually program our PID gains and get everything working ahead of time. And then all we have to do is experiment and running different amounts of dome pressure and seeing what that gives us for manifold pressure. So we'll discuss that relationship in a little bit. Let's jump in here and take a look at how to set all this up. What we're going to do here is jump into our dome boost layout. And then we're going to go in here. This is where we're going to be doing all the programming, and we can see what's actually going on here with the system. What I'm going to do right now is talk about the components of the system, and then we'll assign everything and get everything set up here for this tutorial. So taking a look at this, the schematic coming up on screen, we're going to find we have a whole bunch of different components here. We need to have everything set up exactly as the schematic is showing. If you don't, you won't find the system's going to work properly. You're never going to get any consistency out of your dome pressure control. So the first thing we're going to find here is that we have a CO2 bottle, and it's going to have a regulator fitted to the bottle that's going to be regulating the pressure to the system. Now, the regulator is very important in terms of the pressure it's going to deliver. Let's just say you want to build 400 kPa of manifold pressure out of your dome pressure control. You usually want to run double the manifold pressure in terms of the line pressure coming out of the CO2 bottle. So your regulator then should be set at something like 800 kPa of CO2 pressure. So if you want to run 400 kPa of manifold pressure, run around 800 kPa of CO2 pressure. That'll give the dome pressure control enough range of adjustment that it can reach huge amounts of boost pressure. A lot of times what we're going to find is that once you get up to the really high boost pressures, you're going to find the back pressure starts to become a problem. So how much exhaust manifold pressure is built up before the turbo in the exhaust manifold, and we have to fight to overcome that, which is why we have to have enough of a range, essentially double the desired manifold pressure with the CO2 dome pressure control, what's regulated from the tank, in order to overcome exhaust back pressure so that everything is going to be equalizing correctly in the control system. So that's the first thing that we need to kind of keep in mind. Whatever the manifold pressure, the top manifold pressure you want to run out of your boost control system here, then run double the regulated pressure from the CO2 tank. Okay, the next thing we have here is 2 boost control solenoids. We can see here they're set up very specifically in terms of the orientation. So we're going to find here, looking at the solenoid, from the CO2 regulator, so the regulated bottle pressure, we're going to be putting that into the fill or pressure solenoid. That's going to be going into port 1. Then we're going to find port 3 is going to have a little filter on it. That's a vent. Port 2 is going to have a T. The other side of that T is going to go into the port 1 on a bleed solenoid. Then we have port 3 being a vent, and then port 2 is also going to be a vent. Out of the T, it's going to go right to the top hat port of the wastegate. Then we'll find we have a dome pressure sensor. The dome pressure sensor is monitoring and measuring our dome pressure, or what we're feeding into the top hat of the wastegate. That's what the whole control system is going to be controlling against, the dome pressure. So we want to make sure that we have that sensor fitted. Now, looking at this, you do not want to run the dome pressure sensor near the boost control solenoids. It has to be mounted on the top hat of the wastegate. This particular wastegate looks like a tile MVR, MVS wastegate, so this has a fitting already that we can already thread it into the top hat. Most wastegates will have a second top port threaded fitting or port that we can thread into where the dome pressure can fit. If your wastegate does not have that, you will need to drill and tap it so that it's able to thread in the typical 8th pipe NPT style sensor. So the other things we have here is obviously the wastegate. We have our boost pressure reference going to that lower port on the wastegate. So that is important. You still need to have a boost pressure reference. So the wastegate's going to be opening up based around the spring pressure, and then we're feeding again that CO2 regulated pressure through the fill and bleed solenoids to achieve whatever the desired dome pressure is going to be. So those are the individual components of our system. So in order to set this up, we need to set up and wire 2 boost control solenoids into the link, and then we also have a dome pressure sensor that's going to be wired into an analog input. I would recommend to run 150 PSI dome pressure sensor that gives you up to about 1,000 kPa worth of dome pressure reading. You're most likely not going to be running much higher than about 800 kPa of line pressure coming from your regulator into the boost control solenoids. So that way you just cover your range that you can actually measure and read within your dome pressure. So 150 PSI pressure sensor works fairly well, or 1,000 kPa pressure sensor. Same thing, depending on your scaling, your units you're talking about. So we need to go in and set up these boost control solenoids and our dome pressure sensor. One thing with the boost control solenoids, these are typical 3-port MAX solenoids. They will run at approximately 30 hertz of frequency, and the wiring for the solenoids is pretty simple. 2 wires coming out of each solenoid. There's no polarity on the wiring, so you can wire both boost control solenoids to a Keon 12-volt power source, and then the other wire coming from the solenoid is what we run into the link, and we're going to be low side pulse width modulating the solenoid for the control. Now, the way this is going to work in terms of the pressure, also known as the fill solenoid and the bleed solenoid, as we're trying to achieve a certain dome pressure target, it's going to be pumping so much through the pressure solenoid, and if we're starting to overshoot in the pressure, the bleed solenoid is going to be bleeding off any excess through that port 2. So it's going to be constantly adjusting both solenoids. The way we work with this is definitely a lot different than the manifold pressure in terms of the programming. So let's start to get into the programming here so we can see how this works. Once we program and set everything up, then we're going to take a look at doing the basic setup and configuration with just regulated air pressure before we even run our engine. So we can do this with key on, engine off. All right, let's watch how this is going to be set up here. So under our boost setup, we're going to go to boost mode and we have a couple options. We're going to be choosing, in this case, dome pressure control, and click OK. And we're going to say yes. It's going to ask me to... Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.